Okay, Assalamualaikum warahmatullahi wabarakatuh and hello. Okay, selamat hari raya. Okay, today we'll continue our study with the polynomial, which is chapter 12. Okay, before I continue, make sure you done the quiz. Okay, this week you have to done the quiz and as well as the assignment. So quiz will be open for this week only, and the assignment will be open for 32 days. So for quiz, you have to do it individually, and for the assignment, you have to do it in group of 4 or less. Okay, for quiz is 2%, and for the assignment is 20%. Make sure you done everything. Okay. Okay, before we continue, I just want to show what is polynomial. Okay, so if you recall back, polynomial is basically something like that, like this. Okay, 3x plus 2. This is polynomial. Okay, with one level. Okay, one order of 1. Okay, this one, x to the power of 1. For example, this one, 4x squared plus 3x plus 3 is also polynomial, but with the level degree of 2. So all of this is polynomial. So you can write it, for example, 4x to the power of 8, okay, plus 3 is also polynomial. Okay, for j, okay, j is not a good example because j represent imaginary number. So for hash, okay, squared plus 3 is also polynomial. So for this week, we will how to present the polynomial as vector inside MATLAB. Then you just learn how to write everything inside the MATLAB. And then you also will learn about how to find the root. Okay, remember for 3x plus 2, okay, equals to 0. Okay, 3x plus 2 is equals to 0. You have to find the root is just x equals to negative 2 divided by 3. Okay, and for this example, remember that x is equal to b squared plus minus square root of 4 minus b squared. I think this one is just b minus b squared plus 4ac divided by 2a. So you will get the root, and this is the manual way, and you have to know how to get the root using MATLAB, which is much more easy. And then you will learn about how to multiply and divide polynomial, and also you polynomial to the model a data through a curve fitting. Okay, basically you will learn curve fitting. Okay, curve fitting. If I let me delete this first. Okay, I think you already learned about this, and you also can use your calculator to get a curve fitting. So curve fitting is basically, for example, here you have data here, data here, data here, data here, and you want to curve fit first order, or you have data something like this. Okay, so you want to curve fit second order, it's something like this. Okay, so basically it will try to find a polynomial equation that can try to fit all the data you have. Okay, either it can intercept or not. Okay, basically it will try to find the closest one. Okay, that is polyfit. And polyval is basically you insert the value here. For example, here 3x plus 2. Okay, you insert x is 0 until 10. So basically polyval just insert the value inside this unknown. Okay, so you will learn all 4 things. Okay, like I said before, what is polynomial is basically this. Polynomial is a mathematical expression that consists of sum of many terms. Okay, so remember that for the order, okay, so you have to look at the highest number of x. So this is the level. Okay, So I think what you need to know for polynomial is this one. Okay, polynomial has many applications. Okay, in engineering there are many applications. It can represent a system, system stability. Okay, you can model acquired data, and you can use as calibration. So we will look all of these example, how to use the polynomial inside this application using MATLAB. Okay, so in vector representation, polynomial coefficients are normally constant. Okay, constant and can be grouped into single vector. So remember back what is vector. Vector is just basically a 1 multiplied by x data or x multiplied by 1 data. Basically a long chain of data. Okay, you have a variable here, you have a long chain of data, only one row or one column. Okay, so in MATLAB can be either in form of, okay, this one I already explained. Okay, so with the coefficient of polynomial represent as vector, MATLAB can provide many functions to work as with polynomial. Okay, okay, this is the MATLAB function you can use for polynomial. Okay, for multiplication you can use conv. Okay, and for division, okay, division dconv. Okay, you have two parameter. For example, you have two vector. You have to change it to the you have for example 3x squared plus 3x plus maybe 2 plus 1. Okay, so this is for example y. Okay, so in MATLAB you can write it as y is equals to 3 to 1. Okay, so you could present this as 3 to 1. And maybe for example you have z, another function or another polynomial. So if you want to multiply y multiplied by z, you can use MATLAB, just write con v y z. And if you want to divide, you can use dcon. Okay, so dcon if you want to divide. Okay, so if you want to find the root, okay, find the root. Remember what is root? So this one is equal to 0. Okay, y is equal to 0. You have to solve this. So you can use root. Okay, I will show it to you later. And of course, polyval, basically you evaluate the parameter, and polyfit, you try to curve fit the data with the polynomial equation. So all of this is you will learn how to use all of this MATLAB function. Okay, let's go to the example 12.1. Okay, you open your MATLAB. Okay, please open your MATLAB and try to do this. Okay, how to present this one equation. So this is basically 4 level. Okay, 4 order, 4 3 2 1 0. So you present this as a vector and you can write something like this. Okay, so for example, don't forget y is equals to 3 1 negative 2 0.5 and 1. You can either use space or use comma. Okay, either way you will present this polynomial as vector. Okay, so next example, let me delete this first. Okay, next example, so x minus 1. So this one and this one. So you just write it back. So x means that only 1x minus 1. That's why it will become 1. Okay, how about this? So you can see here you have y squared plus y. Okay, y power of 1. And how about y power of 0? So you have 0, y power of 0. So for this case, you have to write something like this. And make sure you cannot skip the order. Okay, If you have y2, you need to consider the y1 and y0. That's why this one will become 0. So negative 6, 3 over 2 and 0. Okay, so be careful when you want to convert the polynomial into a MATLAB vector. Okay, let's look at example 4. Okay, this one is basically, for example here, x power of 0. So you just write it. Okay, how about this? So x a power of 3. So basically it's 1 a power of 3 plus 0 a power of 2 plus 0 a power of 1 plus 0 a power of 0. Okay, so you have 0 0 0 1. So that's why it become 1 0 0 0 1. Okay, next we look at this example. So you can see here the order is not correct, so you have to change the order correctly first. Okay, you have to change it. So the highest one is power of x2. Okay, power of 2. So negative, don't forget the negative x squared minus 2x minus, okay, for this one plus 1. Okay, plus 1. So after you rearrange everything according to its order, then you copy the value. Okay, so you get negative 2, negative 3, negative 2 and 1. How about this? Okay, so of course you have to rearrange this. Okay, let me delete this, too much clutter. Okay, let me delete this. Okay, we move on to this example number 7. So first thing you have to do is rearrange this. You have to look which is the highest. So 3y squared plus 2y, okay, plus a minus 1. So both of these has the same level, which is y power of 0. So that's why you write something like this. Okay, and next example you can see here. So if you have two unknown, okay, you cannot write both unknown. You have to look at this. What is the function is? Okay, for this case is function of y. That's why we choose y, not a. And for this case, we also have to choose y. So you look at the y. Okay, this is y, this is y. You have to look at the highest one. So 3xy power of 3. Then you look at the power of 2. There is no power of 2, so just 0, y power of 2. And then x power of y1 plus x power of y1 plus y0. So only 1. 1, y0. So after that, you convert this into a vector. So 3, okay, this one is 0. This one is x. And this one is 1. Okay, so it will become like this. Okay, let me clear this. Okay, let me delete this first. So you have to practice how to convert the polynomial equation into a vector representation inside the MATLAB. So then we look at example 9. Okay, you look here, this is x. So function of x. So you have to look at x. Okay, so you can see here the highest one is x power of 1. So of course you group it together. So 3y square a cube plus y x and plus 1. So if you convert this, 3y cube plus y and 1. This is how you present the vector. Okay, and lastly this one. So let me delete this first. Okay, Let me check this. Okay, so you can see here you have to multiply this with this and this first. So ax squared plus ax plus x minus 3. So of course you have to group it together because this is a x function. Okay, so ax squared plus a plus 1x minus 3. Okay, so after that you convert to vector, which is a. Okay, and then don't forget the square bracket, a plus 1 and then minus 3. Okay, so this one. So you have to practice how to do a polynomial conversion from polynomial equation to vector representation. Okay, make sure you know how to do this. If you fail this one, you cannot answer anything else. So now, after you already change it to vector representation, you copy this. For example, you already convert this. Then you can insert this into a MATLAB. So for example 1, I call it A. Okay, equals to this one. Okay, I cannot just copy this. So I just have to manually copy this 3 space 1 space negative 2 space 0.5 space 1 square bracket close. Okay, so you get something like this. Okay, it will present something like this. So this is x power of 4, x power of 3, x power of 2, x power of 1, x power of 0. Okay, make sure at the end is the x power of 0. Okay, same as here. Okay, how to present this? Example b is equals to 1 is negative 1. Okay, so you can look here. It will show the polynomial something like this: x power of 1, x power of 0. Okay, that is how you insert this vector inside the MATLAB. Basically, it's just a same vector as before you learn. Okay, in chapter 2. Okay, as I mentioned before, you can multiply or divide the polynomial. So for multiplication, you use con v. Okay, if you want to divide two polynomial, you use d con v. Okay, for this you have to be careful. So you have two output. Okay, so this is the result. Okay, this is the result of the multiplication. It's simple, it's just one way. But for this case, you have w and r. Okay, so what is w, what is r? W is just the result of the division and r is the residual. Okay, so what it means that if you, for example, you divide u and v, so u divide by v, of course you get the answer w. Okay, and then you have residual plus residual, and don't forget to divide by v. So this one cannot be divided, so that's why you have to write this like this. Okay, so example I will give you later. Okay, so make sure you know how to what is w and r mean. So this one is just a residual, not residual, remainder, sorry, remainder of the polynomial long division. Okay, so basically you divide it and you plus and then divide by the v divider. Okay, so we start with example number 2. Okay, on multiplication and division. So you have this one. So you have function a is this one and function b is this one. So 1 3 0 2 is just this one, and 0 1 negative 5 is this one. Okay, you can see here 0 because x, we have 0 x power of 1 inside here. So but 0 is just empty, so make sure you include it inside there. Also same with here, x power of 1 is 0, means that you have to put 0. So be careful, okay, when you want to convert into vector, polynomial into vector, you have to consider the empty, okay, the 0 component, this one and this one. Okay, so you have A and B. So for the first example here, find this one. This one is basically multiplication. So if you want to do this manually, you have to multiply all of this with this one first, and then plus multiply all of this with this one. So it is difficult, but if you use MATLAB conv, okay, conv with this, it is just multiplication of polynomial. So automatically you will get the answer here. Okay, so what is this mean is that, okay, you can see here this one is 1 2 3 4 5 6. You have 6 vector. Okay, 1 multiplied by 6 vector means that you have power of the highest number is the x power of 5. Okay, where you get 5 is basically 6 minus 1. Okay, so pick 6 minus 1 is 5. And then you have to copy all of this back. Okay, so 1 is 1x power of 5 plus 3x power of 4 plus, not plus, minus 5x power of 3 minus 13x power of 2, okay, minus plus 0x power of 1 minus 10 power x power of 0. So this is not a simplified version, so you have to make sure it is simplified. So x5 plus 3x4 minus 5x3 minus 13x squared, okay, plus x 0x1, basically you just ignore, and minus x x power of 0 is 1, so just multiply by 10. So you get the answer. Okay, make sure you know how to convert from polynomial to vector, and then you need to know how to convert the vector to polynomial. Okay, so let me clear this first. Okay, okay, so next example is division. So for division, you can see here this one is divided by this one. So basically this is A, this is B. So A divided by B. So what is x cubed plus 3x squared plus 2 divided by x squared minus 5. Okay, you have to do a long division. So it is quite difficult to do it manually. Okay, you have to recall back how to do it. But if you use this decon, you can get the answer easily. But make sure you have to set two parameter. Okay, you can see for multiplication is easy, you just have one answer. But for decon, you have division result as well as the remainder. Okay, remainder. Okay, so when you do this, you get 1, 3, and the residual, a remainder is this one. Okay, so how to convert this into a polynomial back? So basically, if you, let me clear this first. Okay, okay, you can see here, this is the first one, this is the result. So of course you can look here, this one is this one, you have 2. Okay, 1 multiplied by 2. Remember, if 1 multiplied by 2, the highest order is x 2 minus 1. So this one, take this value and put here minus 1. So basically the highest value is x power of 1. So after that you can just write it back. So x plus 3. Okay, x power of 1 is x plus 3. X power of 0 is 1. Okay, so you get x plus 3. And don't forget the remainder. Plus, you can look here, the remainder. So another way is easier is you look at this location, the n. So this is represent x power of 0, x power of 1, x power of 2, x power of 3. So if you look x power of 0, so basically plus, okay, the remainder is just 5x minus, oh not minus, plus 17 x power 0 divided by, don't forget the b, okay, remember the division. So x squared minus 5. Okay, that is how you rewrite again the answer from the vector. Okay, this one is basically this one. So make sure you know that skill, how to convert the polynomial to vector and convert it back to polynomial. Okay, and make sure you understand what is this vector and remainder vector. Okay, system representation. So many engineering related system can be represented in mathematical model. So maybe you have a motor, you can present it as a mathematic model. Okay, motor, what else? Power converter, anything, most of the engineering related problem system, you can change it to mathematical model. Okay, so one of the way is to represent the model in the polynomial form. Okay, so you can represent a system, okay, system response in the polynomial form. Electrical and electronic is not an exception. You can present this into a polynomial form. Okay. One case is when the system is presented in Laplace domain, where S is used as polynomial variable. So S, so usually I think you already look something. You look this. You can represent anything in time domain. So 3t squared plus 3t plus 3. So you can represent this with time. But another way is you use Laplace domain. You present all of this into a, okay, in frequency domain. Okay, S domain is basically something like frequency domain. S is just represent as j2 pi f, if not mistaken. I forget already. But you can represent S is as a frequency domain. Okay, so this is a system function. Okay, so basically the polynomial is a very good thing that you have to learn to present a system, especially in electrical and electronic. Okay, I think most of you still not learn about control, but this is basically what is control. Okay, so you have a hash. Usually hash is representing the system. Okay, motor. Okay, motor, car acceleration, pedal, compressor, anything. Okay, so it is called a plant. Plant hash. Okay, plant is basically a system. Okay, this system, not system, but the thing that you want to control. Okay, so G is the controller. Usually we use a DPI. You can use PI, P controller, PI controller, okay, and many more. So basically this is a controller. So this one is presented as G. Okay, or lead lag controller, all of this you can put here. So this is the output of the plant. For example, if motor, the output is torque or speed, something like that. So the output, this is the input. For example, here maybe the voltage. Okay, you insert the voltage here, input, and the output is the speed, for example. and the voltage is controlled by the controller. Okay, so let me delete this. So I give you examples of motor. So if, for example, you have speed, so you have motor here, so you have voltage. Okay, this is controller. Okay, so you have either PI, PID, depend on you. So the controller will produce a correct voltage for the motor to produce a speed, and this speed is negative feedback. You can see here this negative feedback. Basically, it will compare. This is the input, system input. Okay, for this case, I suggest desired speed. This one is real speed. So for example, you want 100 RPM, 1000 RPM. Okay, 1000 rotation per minute. You set it inside here, and the real speed is compared with the desired speed here. Okay, and the difference will produce an error. Okay, the error will be used by the controller here, okay, to produce a correct voltage for the motor. Okay, this one is basically the closed loop. Okay, so basically it will try to control it until the error is 0. Okay, and how we use polynomial? So basically, if I delete this back, okay, so remember that I say, for example, motor can be presented as a polynomial function. Okay, so in terms of S, okay, S domain, and PID controller, this is PID controller. Okay, you can represent the PID controller as this. So with this here. Okay, and Q is basically, okay, this one is, I think you have to learn it. G hash divided by 1 plus G hash, if not mistaken. Okay, so you have to multiply this with this, you get Q. Basically, you have a one system Q, you have input here, you have output. Okay, all of this you will learn in control. Okay, maybe in third year, okay, you will learn this, but basically you will use polynomial to solve this problem. Okay, so recall back the PID controller. Okay, remember PID controller. So this one, this is a PID controller, ds squared plus ps plus I divided by S. Okay, so basically how to present this? Okay, you have, this is G, right? So GS is this. Okay, and to convert this into vector, you have G numerator, G denominator. Okay, you have the top one and the bottom one. So basically you convert this into dpi. Okay, it becomes like this. Okay, and for denominator, of course, s plus 0, s power of 0. So basically 1 0. Okay, be careful, you cannot just ignore this. Okay, so this is from the previous equation. Okay, you get the denominator. And for the system, assume that the plan, okay, remember the plan is hash. So hash is this one. So numerator is 1, denominator this 1 minus 1s minus 2. So this one. So you have to write all of this system. Okay, and so remember back the equation, G hash divided by, okay, G hash Okay. Wait, So if you recall back, I said that, okay, for Q is for the overall, for the closed loop system. So Q is equal to G hash divided by 1 plus G hash. So another way to write this, okay, when you basically change it into a different form, you divide into numerator and denominator. Okay. So basically for control, let me memorize it back. Okay. So Q is equals to QS actually, because this is a function. So QS equals to GN hash N. So numerator, you just take the top part. Okay, the top part. Okay, divide by, okay, G and hash N. Also the top part plus G D hash D. Okay, so this is basically after you do some manipulation, you get this answer. So basically Gn hash N divided by Gn hash N plus Gd hash D. Okay, after you do some manipulation. So basically to get Q, okay, so Q numerator you just multiply the top. Okay, and for the denominator, remember here you have to, I change pen. Okay, okay, Gn hash N is basically the Qn. Okay, it's the same thing, and plus Gd hash D. So you have to multiply this. Okay, that's why you have to use this. Okay, and add poly. Okay, this is another function. You can add the polynomial. Okay, basically this is the first one, this one. Okay, and this is the second one. You add this and this. So after that you get the overall system. Okay, I suggest you memorize this equation. Usually they will give the final equation, the closed loop equation, but you, I think this one I suggest you memorize it. Okay, but don't worry too much because usually they will give this. So your basically you have to solve the system. Okay, the closed loop system. This is the answer. Okay, and of course you need to know how to change it back. Okay, let me delete this. Okay, how to change this back. So remember that this one x power of, not x, s. Okay, for this one you use s. So s power 0, 1, 2. So 2s squared plus 4s plus 1. Okay, divide by, remember this is numerator, this is denominator. Okay, so 3s squared plus 2s plus 1. Okay, so qs. So this is basically the overall system. Okay, this is how you determine the response of the system. Okay, that is basically how to solve the system function. So make sure you know how to do this. So if you check back, add poly is basically a user defined. So basically add poly, okay, add poly is not available in MATLAB. So you have to create this function on your own. So I include the function here. So make sure you know how this function works. For example, if a is equal to 1, 2, 3, okay, of course this one, b is equal to 4, 5, 6, 7. Okay, first thing you need to know is you have to flip this. Okay, in order to operate this properly, you have to flip this. So basically the new value is a is 3 to 1 and b is 7, 6, 5, 4. you just use the flip function. Okay, and then you check the length. Okay, the length of each. So for A, the length is 3. Okay, for B, the length is 4. So remember that when you want to add a metric, you need to have the same value, but the problem is not the same. So in order to fix this, okay, you have to make sure that you have to add another 0 here. So you have to change A to 3 to 1, 0. So then you have 4 and 4. To do this, you have, for example here, so I is bigger than J, so this is not true. You go to here. So you have to make sure the size of A is much more larger. So first thing, you have to create 0. So A is 0, 0, 0, 0. Okay. And then you insert the value, okay, A inside here. So basically, you insert this A, original A. Okay, insert it 3 to 1. And then lastly, you convert this value into the original A. Okay, equals to 3 to 1, 0. Okay, and then you can add it together. So B is, okay, 7, 6, 5, 4. Okay. Okay, this is the power of x equals to 0, x equals to 1, x equals to 2, x equals to 3. Okay, so you add this, you get 10. Okay, 6 is 8, 1 5 is 7, 6, and 0 is 4. Okay, you get C is this one. But unfortunately, in MATLAB, we cannot use this format. It is another way around. So you have to flip back the answer. So C will become, okay, so 4, 6, 8, 10. So that is how you create a add poly. So you can copy this function. Okay, take 5-minute break and we will continue with the polyval. Basically, we insert the value inside the parameter, okay, the term. Okay, we continue our study with polyval. So basically, polyval, this one is basically, this is your polynomial and this is your parameter. So like I said before, if you have y squared plus y plus 5, so z is equals to this one, and you want to, okay, maybe I give you more close to this one. Okay, so y is equals to x squared plus 2x plus 3, for example. So you want to know what is y if x is from 0 to 10. So in order to analyze this, you use polyval. Okay, that's it. You just insert x into here. So how to do this? So basically, you have a function here. Okay, you have x squared x cubed plus 4x squared plus 2x plus 1. So of course, you have to change this into the vector. And then you want to find what is x when what is x for 3.5. Okay, so basically you just polyval the p and insert the x, okay, the value number. So you will get the answer. So this is a simple example. So you can try this. This one is simple, but if you have a, for example, x is from 0 to 10, it is much more difficult to analyze this. Okay, so I will show you in the next example. So frequency response. Okay, this is one of the application. Okay, for polynomial. Okay, so basically what is frequency response is basically you have a system. Remember that you look at the system QS. Okay, you want to know whether the system is stable or not. So in order to do that, you have to do a frequency response analysis. You have to look at the response when the frequency, which is S, is vary. Okay, so this one you will learn in chapter 3, but you don't need to know about this. Only you need to know how to produce the output. Okay, you don't need to understand how to produce what is the output meaning. Okay, you just need to know how to produce the output. So remember that the closed loop system is QS, and you have numerator and denominator. Okay, and yeah, this one. So S actually J 2 pi F. So the frequency is vary. Okay, frequency is in hertz. So J is the imaginary number, 2 pi is the constant. So F must be determined, okay, it must be vary from 0 to 10 kilohertz. Okay, that is how you analyze the frequency response. Okay, so basically from the frequency response, you can know whether the system is stable, unstable, or partially stable. So make sure you know this one. S is equals to J 2 pi F, and the frequency is vary. So how to do this? Of course, you have to insert the system first. So you have a Qn numerator, Q denominator here. Okay, and then you have the frequency here. You vary from 0 to 10 kilohertz. Okay, with a step of 1. And of course, you have to convert it into the S domain. Frequency, okay, both are frequency domain, but S domain is basically you have this one. Okay, this one. Okay, this equation. So basically, so you have to put 1. You cannot just put I. You have to put 1I. Okay, multiply by 2 pi F. Okay, you just multiply it. Okay, and then of course you have to polyval. Okay, polyval. Okay, evaluate the Q and numerator and with the S. Okay, the S. And denominator also you have to polyval the denominator and with the S value here. Okay, and of course you have to divide, okay, to get the whole system. So basically Q numerator divided by Q denominator, because this is a what you call a vector. Okay, you have to do the array operation. Basically array operation you have to put dot. Okay, don't forget to put dot, if not it will not work. Okay, so you have complete analyze the frequency response. Now you have to plot the output. So you have to recall back your, I think, chapter 7 on the input output or graphic representation. So remember that you have semi-log x. So basically semi-log means that you have one is linear, okay, basically the normal graph, and one is the logarithm graph, and the logarithm graph is in x. That's why it's called semi-half log x. Okay, semi-log x, which is the log is on the x axis, which is the frequency. So you insert the frequency and you insert the absolute. Okay, so if you have a system like this, you can use, if you want to look the magnitude, you have to use ABS, and if you want to see the frequency, is phase. Okay, phase the system. Okay, QS, this one. Okay, so you have to know these two, ABS and phase. Usually frequency response involve, okay, you have magnitude, which is ABS, and the angle, which is phase. Okay, make sure you know this. Okay, of course you have to give the title and everything. So this is basically the result. Okay, in your class you don't need to understand what this means. Okay, you don't need to understand why this is like this, why this is like this. This is for third year, when you learn about the control. Okay, but you have to know how to produce this. Okay, frequency response, very useful tools in engineering. Okay, another function that is useful in MATLAB is roots. Okay, basically roots is you want to find the f(x) is 0. Okay, so for example, I give you example before is for example y equals to 3x plus 2, 3x plus 2. So when y is equal to 0, x is so negative 2 divided by 3. Okay, so this is root. Same as y equals to 3x squared plus 2x plus 2. Okay, so y is basically b, negative b, remember, negative b plus minus square root of 4 b squared minus 4ac divided by 2a. So basically this is how manually you get the root. But if you use MATLAB, you just insert this code. You insert the polynomial, automatically you get the root. So how to use it? So basically you have to convert this equation into the vector. Okay, and then you just use this inside this, then you get the root. So you get 2, negative 2 and 1. Okay, that's it. Okay, this is how you get roots from the polynomial. Okay, I give you example of the application of roots, okay, which is vertical displacement. So you have a displacement here, you have velocity, you have time, you have gravity, and you have also time. So launch an object into the ground vertically, and how long does it take to go back to the ground? So basically you have ground here. Okay, you have an object thrown. Okay, and then how long does it take it to go back down? So what is t when d is equals to 0? So basically you have to find the root. So of course you have to convert this into a vector first. So you can see here 9 by g divided by 2 t squared plus vt. G is this one, t is v is this one. So you just insert this value. Okay, this one is g divided by 2, this one is v, this one is, of course, don't forget the t power of 0. Okay, make sure you don't forget this. Usually student will forget about this. And then of course you already have this, you just use root. So you get the answer. Okay. And of course for this case you cannot the time will be 2. Okay, 0 and this one. This one is just to eliminate the time is equal to 0. Okay, and for this case it's just to plot the displacement. Okay, this one is the parameter you learned before, the function you learned before, polyval. So you have time is from 0 to t ground. Okay, basically this one, from this one, and the step is 0.01, and d is polyval p. Okay, basically you will evaluate all the polynomial number with this t. Okay, you can see here the example. Okay, previous example only use one value, but for this case is multiple. Okay, multiple value, so you can produce multiple d. Okay, so you have to plot it and you will get the plot. Okay, so basically this is the plot. So this is time, okay, time and the displacement. Okay, at time 6 seconds you get the object will fall to the ground. That is how you use the the roots function as well as the polyval. Okay, this is a very useful in the vertical displacement. Okay, let's take a look another example, which is system stability. Okay, so this is another application of polynomial. Okay, if you look at example 12.3, the stability of system of polynomial can be checked by the root. Okay, you check the root, you know the system stability. So how to do this? Of course, let me show you using code. Okay, so you have to create a function here. Okay, so the user-defined function is called check stability C, which is the controller, Pn, and Pd. Okay, so let me clear this first. So okay, so we start with the C, which is controller. And remember the PID controller is C as is equals to or in this case G, right? If you check previous example, GS is equals to D S squared plus P S plus I divided by S. So if you look here, C, so if you look at C, okay, for C is, so if you insert the value C is basically 3 number. Okay, so you take the third one, the first one, the second one. So C is basically P I D. Okay, you insert the value here and it will be extracted inside here. So 1 0 is the S. Okay, so this is the controller and this is the transfer, the whole system. If you refer back, it is Q. Okay, remember Q is G and P and okay, P is the plan, or for this case you see as hash right before, but this is show as Pn, and of course G and Pn just copy back and plus G numerator D P numerator. So this is just the previous formula. Okay, Pn and Gn is the plan formula. Okay, so plan Ps is equals to P numerator divided by P denominator. So that's it. The first one is basically just the system. And don't forget, add poly is not available in MATLAB. So you have to create on your own. So I give you the coding in the previous slide. So you have to create this function first, then you can run this. Okay, if you don't create the add poly function, okay, you cannot run. Okay, so we finish off with the first explanation. You just create the function. Okay, let me clear this first. And then next part is root. Okay, you find the root. So basically, you just use the MATLAB function called roots. Okay, you have HD. Okay, when it comes to stability, okay, when it comes to stability, you only analyze the whole system Q. You have for this case you use hash, right? So I use hash as okay whole system. okay, the whole system, which include the controller as well as the plan. So hash n and hash t. So to analyze this whole system, you only have to analyze the root for the denominator only. This is for chapter 3, the control. You don't need to know too much. But basically, if you want to know the stability of a system, you look at the root of the denominator. So that's why you analyze the denominator part. Okay, and then you set the length and you print the root. Okay, so this one you just recall back your fprintf. Basically, you just print the root. Okay, and then that root, you analyze that root. Okay, if you look here, root, you call back the root here, and or if the root is more than 0, okay, you keep it. Okay, if there is still is empty. Okay, wait. Okay, if you check if the root is more than 0, okay, you keep it. And okay, if it is empty, the system is stable. And if the root is still not empty, if not empty, the root is unstable. So that is how you determine the root is stable or not. Okay, so let us test this. Okay, if you check back the condition, okay, if the root is more than 0, it is stable. Okay, if the root is more than 0, it is unstable. Okay, more than or equal to. So if you check here, okay, you can see if you run, okay, you already save the function, okay, and you run it back, okay, you run it back, okay, this is the root, the result, okay, and you can see here this is not more than 0, so it is stable. But for this case, okay, this one is more than 0. Remember, see this is more than 0, and for this case, more than or equals to, this is 0 also. So of course it is not stable. So this is how you use the polynomial inside MATLAB to determine the system stability. Okay, so make sure you know how to do this. Okay, how to get the root, how to analyze the root. Okay, take 5-minute break and we will continue with the next part of this chapter, which is the polyfit. Okay. Okay, we continue with the next part of this, which is polyfit, or basically a curve fitting. Okay, so remember in the previous chapter we learned about the interpolation, and curve fitting. Okay, so make sure you know the difference. Okay, interpolation, basically you have a data here. Okay, you have a data. Okay, interpolation is basically you try, okay, you create a function that meet all of the data. That is interpolation. But curve fitting is you have a multiple data, okay, with some error. For example, okay, something like this, okay, and it will create, for example, if you choose a linear equation, okay, y equals to mx plus c, for example, you try to find the best linear equation that can produce a minimum error. For example, you fit only to this. Okay, so you have a little bit of error here, a bit of error, and error. So basically, it's try to fit into a polynomial. Okay, interpolation, you fit everything inside that. But curve fitting is basically you try to find a polynomial equation that fit with the data. That is, to do this in MATLAB, you use a polyfit. Okay. So of course you have P is equals to polyfit. Okay, you have the X data, you have the Y data. Okay, of course you have something like this, right? You have X, you have Y, you have first data, and then you have the second data. Okay, you have multiple data for X and Y. Make sure it's the same length, and the degree of polynomial fit. Okay, this one is the linear equation. So just something like this. So 2 is the parabolic, right? Parabolic. So something like this or something like this. Okay. Third polynomial is this one. Okay, this one is x3 plus x2 plus x1 plus x0. Y equals to. So linear equation is the y equals to mx plus c. Of course, parabolic is y equals to x squared plus x plus c. Okay, so basically you look at the highest order. So linear equation x is 1, parabolic is x is 2. So this is the polynomial degree of fit. So you just put either 1, 2, 3, 4 and so on. Okay, so that is how you use polyfit. Okay, so like I said before, curve fitting is basically you have a bunch of data. You want to find the equation. Okay, fx. What is equation? So basically from data you convert it to equation. Okay, curve fitting is the process of construct a curve series from data and presented in the mathematical function as polynomial. Okay, that is curve fitting. Okay, it is very useful in the modeling yearly climate data, modeling internet usage, okay, automation, data trending, and data relationship. Okay, so you can use the curve fitting with this for this problem. Okay. Okay, I give you a first example. Okay, first application for the curve fitting. Okay, which is sensor calibration. I think many of you will be using this in the final year project. Okay, you have to calibrate sensor. So to do this, you need to have various data here. Okay, sorry, I still not get this data. So you can just try to understand this. Okay, so basically the data contain temperature sensor reading in volt. Okay, basically you have a sensor here. Okay, and then you have the temperature. Okay, you convert the temperature into volt. Okay, and the voltage can be read by the microcontroller. Okay, and you can process the data for the response. So basically, sensor for electrical sensor is usually converted to electrical that can be read by the microcontroller. Okay, so the temperature sensor reading is in volt, taking by the temperature between this. Okay, so find a mathematical function. So inside the microcontroller, it's hard. You have to have a function. Okay, so for this volt, what is the temperature? So the temperature convert to voltage, and then you have to convert to the temperature back. Okay, that is how the sensor works. So temperature, okay, convert to voltage, okay, by the sensor, okay, and then by the microcontroller you convert this into the temperature back. Okay, usually in application of sensor we use this approach. So how to find the mathematical function inside here, how to convert this into this? So you have to find a y equals to something. So how to do this? You use curve fitting. Okay, you have multiple data, then you try to fit it, and you get the answer. So the solution is 2. Okay, basically you done the calibration. Okay, when you come to sensor, you need to done the calibration. This is the calibration. Basically, you use curve fitting. Okay, so to do this, you use curve fit and also Polynomial. Okay, to test the output. Okay, you have to use, usually you use this both to ensure that the value used is the same. Okay, so this is how you do it. Okay, sensor calibration. So of course you have to call the data first. Okay, I don't have the data, so you have to call it and you take the data. Okay, okay, you have voltage and temperature and you polyfit it. Okay, so voltage, because you want to convert voltage to temperature, basically output input, right? So this is X, this is Y. So that's why you have to put the input first, X, and then Y. And for sensor, for this sensor, usually we specify it. Okay, so assume that the sensor is linear. So if linear, okay, remember linear is Y equals to mx plus c. So linear. So linear is the degree is only 1. Okay, remember x out of 1. So that's why the degree is only 1. Then you get the answer. Okay. So basically P is, because this is 1 or 1 degree, so means that you have the answer. Remember y equals to mx plus c. So you will get m and c inside the P. Okay, that is the first level. Okay, if you use third level, you get the P will get, okay, a, b, and c. X squared, ax squared plus bx x squared bx plus c. So this is the equation. Basically, you get the polynomial. Okay, and then you print the value. Okay, so print the polynomial. So this is the result. So basically, the temperature V is equals to 16. This one is m v. Okay, T equals to mv plus c. Okay, so this is the value. And then of course you have to test whether the polyfits is accurate or not. So to do this, you have to use polyval. Okay, polyval P and V. So of course V is the original data, the X, and P is the new polynomial here. You insert it back and you get the temperature. Okay, and then of course you plot it. Okay, plot the original data with X and then plot the polyval. Okay, the fitted polynomial equation. Okay, so you can see here, after you plot, you can see this is the curve fitting. Okay, basically you use the poly fit, okay, to get the curve fitting data. Okay, this is the X1 is the original data. So basically you can see here the equation is highly accurate. Okay, that is how you calibrate a sensor. Okay, make sure you know this because it is quite useful, especially in your final year project. Okay, I give you another example is data trend. Okay, the same thing, you use curve fitting based on the data. So for example, this one, I think you also cannot use this because you don't have this file. Okay, so this is the internet usage by the 5% age above 30. So first month, second month, third month, fourth month, and so on. And this is different person. Okay, you have the data, and then you import the data here. Okay, you have the data. Okay, you have the month. Okay, each of them have 1 to 6 months, and then you do the polyfitting. Okay, so polyfitting for this case, okay, you vary the degree. Okay, okay, if you look here, the data is unknown. Okay, you don't know, you still don't know what is the equation, the polynomial that can fit the data perfectly. Okay, you don't know which one is good for this plotting. So to do this, usually you have to choose variable value. Okay, different value. Okay, you have to test this one by one. Okay, if the data is follows the curve fitting, okay, you use that degree. Okay, so that's why you have to manipulate this data. Okay, and then so month fit. Okay, so data fit, this one is the basically you evaluate. Okay, of course poly, well, you evaluate back. Okay, you determine whether this function is accurate or not. Okay, and then of course you plot it. Okay, so you can see here you have the data, first order, second order, third order. So you can see which order is much more accurate. So if you look here, the third order is much more accurate. Okay, the first order is, the second order also still not follow the data, but the third one is much more accurate. Okay, so see here, the above figure, the second order and third order fitting are more accurate to represent compared to the first order. So maybe the first and second is much more, is in the same location, so that's why you cannot see this. So thus the second order is chosen. Okay, usually we choose the lower order. Okay, because higher order is harder to compute. Okay, you try to choose the lower one. Okay, that is how you find the equation, polynomial equation function from the data trend. This one is also very useful, especially in your experiment. Okay, so try to know how to do this. It is very useful. Okay, after you get, okay, you get the polynomial function, you can estimate the future event. So to find the internet usage for month 7, okay, previously you it is given only 1 until 6. Then from after you get the function, okay, function that show the usage, okay, now you can estimate, okay, the future data. Okay, that is why the data curve fitting is very useful, because you know you can estimate the future trend of the data. So to do that, you have to use a polyval. Okay, okay, we look at another example, okay, which is data modeling. So you have various data. So this file I will include it in e-learning. Okay, you can use this file. Okay, and it will not show the same answer, because this file I create my own. Okay, because I still don't obtain the file, the original file, but the result is almost the same. So basically, a farmer want to automate the irrigation system. So he want to know where, on what day, what is the water use. So from the data, he want to create a data model. Okay, so to do this, you want to know Okay, you want to calculate the curve fitting. Okay, you want to know the error. Okay, how to measure the error between the data and the polynomial equation? We call it R square. So this is the equation. So basically, R square method is just you look at the curve fit data and you compare with the original data, you minus it and square it and sum everything. Okay, you have multiple data, right? So you sum it. Okay, for example, you have 1, 2, 3, 4. Okay, you have something like this. Okay. Okay, the line is the curve fitting, and this is the original data. So how to do this is basically you calculate this, the error. Okay, you calculate the error. You this point minus this point, and then you square it. Okay, and you do the same. You find this, you sum this, the error here, the error here, the sum, and you sum this. You sum the error 1, error 2, error 3, error 4. You sum it and then, you square it first. Okay, you square it first and then you sum it and you divide by the original value. Okay, so so you divide with the original value, the measured data. So basically, so divide by this data. This data, don't forget to square it and sum it. Okay, so d squared, d1 squared, d2 squared, d2 squared, d3 squared, d4 squared, and then you sum it and divide by this one. Okay, and then don't forget to 1 minus. Okay, that is how you calculate the error. Okay, if the error is small, okay, R squared will become 1. If the error is very large, R squared become smaller. Okay, so you want the R squared is 1. That is the best result. So of course you have to, to do this code, you have to collect the data first. The data is in the Excel. Okay, the day you save here, the raw data of the water also save here. Okay, and this one is number of the level. Okay, so how much level you want. Okay, and this one. Okay, so if you look here, you try to understand this one is just to create a polyfit. Okay, okay, for the first, second, third, fourth, 5. Okay, fifth level. Okay, fifth order. Okay, so you create a polyfit for the first order, second order, third order, fourth order, sixth order. So basically P is just, okay, you have 5 row, okay, and 5 column. Okay, okay, so you have this one, okay, your polynomial data fitting. Okay, and then this one is polyval. So for this case, you analyze the result, okay, with this. So water fit will something like this. Okay, you have 5 and then you have D. Okay, so this one, okay, something like this, or flip, if not mistaken, flip. Okay, so you print the label. This one is for the legend. Okay, and then you calculate the R squared, okay, which is the error. So 1 minus sum of water feed minus water. Okay, then square it. Okay, this one is array operation, and okay, this one is array operation. So this one is the original data, this one is feed data. Okay, so of course you print it, you plot it. That is how you do the data modeling. Okay, let us analyze the coding. Okay, you can see here the coding is, okay, I run it and I put a breakpoint here. You can see here the water data and the day data is imported here until 45 days. Okay, this one water already imported here. Okay, so X is the original, so no need to worry, it is just to separate this. And N is the number of polynomial order. Okay, we plot 1 until 5. So you create a zeros. Okay, this one is called zeros. Basically, you create a 0 here. 5 multiplied by 5. Sorry, 6 multiplied by 5. So the polynomial is saved here. So the first order, the second order, the third order, the fourth order, and the fifth order. Okay, and then this is the what analysis data, the val hourly val. So you save it here. So you can see here, first order, second order, third order, fourth order, sixth order, and it is run until 45 days. Okay, so of course you start from the first order. Okay, first order. Okay, this one is the how to place the data. So you can see here, let me, okay, where is it? Okay, you can see here, and if I step this, so it will analyze polyfeed with the first order. Okay, and then you analyze the water feed. Okay, so water feed originally is zeros. You run this and you will get the analysis data. Okay, so then this one you just create a label. Okay, that's it. And then you calculate the error. Okay, so calculate the error using R² method. Okay, and then this one is just printing and plotting. So try to understand this. Okay, and this is the result. So you can see here, fifth order will follow it correctly. Fourth order also follow it correctly. Okay, if you look down here, the R², okay, or basically error. Okay, and remember that the closer the R² to 1, the better is the result. So if you look here, you can see that order number 3 and 4 has the lowest error. And if you increase more, the error become, okay, lower. Okay, so since R² for the third polynomial is 0.9991 can be considered good enough, so best polynomial order is 3. So that's why you have to be careful which order you have to choose. The lower is the better, but make sure that the error is not too large. Okay, that's why we have to properly analyze it. So you can see here, this is the polyfeed equation. Okay, you can just call the data using this code. Okay, and after that you can convert it into this. So days and water. So how much water at different days. Okay, that is how you do data modeling. And this is the result. Okay, you can see here for third order, purple is not because it is overlap. So the data fits perfectly, not perfectly, but closely. Okay, you can see here there is still some error, but still close. Okay, for practice, you can try to solve this. Okay, try to solve this. Okay, okay, that's it. Okay, we have finished chapter 12. So today we have learned how to represent polynomial as vector inside the MATLAB. Okay, this is the first skill that you need to know. And then you also learn today how to find the polynomial root. So basically from the polynomial equation you know how to find the root. So root is basically fx is equal to 0. Okay, when the polynomial is equal to 0 you find the root. So you can use MATLAB coding called roots to find it. Okay, and then you use MATLAB to multiply and divide. So today also you have to learn about conv and deconv. Okay, divide. Okay, and what is the function, what is the meaning of reminder. So for division you have a reminder, so you have to know how to do this. Okay, and then lastly you learn about polyfit and polyvol. Okay, these two code you learn and you apply to several example. Okay, several application in engineering. Okay, so make sure you know how to use all of this. Okay, don't forget to do the quiz 2, which is 5%, quiz 2, and assignment 20%. Okay, assignment. Okay, and this one is in group of 4 or less. This one is individual. Okay, you can try do this. Okay, so that's it. For the attendance, make sure you check in your attendance. I will provide the attendance link in the e-learning. Okay, so that's it. See you again next week. So and before I forget, on Wednesday I think there is a holiday, so there will be no class. Okay, see you. Selamat Hari Raya.